Hello again, class. Today we're going to work on calculating the total resistance in a parallel circuit. Last time we did in a series circuit. Please notice that I've got Ohm's Law over here. The current is equal to the voltage divided by the resistance. That current is measured in amperes, symbol A. We can also call current the amperage, and it's the volts divided by the resistance in ohms. Again, there's that symbol omega, the Greek letter, last letter of the Greek alphabet. To calculate total resistance in a parallel circuit, which we'll see in a moment, the formula is 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth for however many resistors in parallel you have. Let's look at what that's going to look like. As before, I suggest you pause here and copy down these steps into your notes. If you follow these steps, you will be able to calculate this with ease every time. Step 1, calculate the total resistance for the circuit. Step 2, you'll calculate the current, same as before. Step 3 is where things are different. In this case, for a parallel circuit, you'll calculate the amperage for each resistor. In parallel circuits, the voltage is constant throughout the circuit. We'll see that in a minute. And step 4, make sure that the total amperage is equal to the sum of the amperage at each point. We'll see how that works in a minute too. So a parallel circuit looks like this. When we saw previously, we saw that the resistors were all in the same loop. That loop is what a circuit is. In this case, the loop splits into two streams. Part of it goes this way, and part of it goes around this way, so that the electricity flows at the same time through each of these, rather than one and then the other. So, if this is a 4 ohm resistor, and this is a 2 ohm resistor, using that formula, 1 over RT equals 1 over R1 plus 1 over R2, we get the total resistance, or the inverse of the total resistance, is equal to 1 over 4, that's your 4 ohms, and 1 over 2, that's your 2 ohms there. Let's start to work this math. 1 over RT is therefore equal to 3 over 4. From here, if you had your school calculator, or if you find something similar online to do the same things for you, you could plug it in, let the calculator solve it for you, and be done. But if you don't, you'll have to do a little bit of algebra. So let's see that algebra. If I've got 1 over RT, I'm going to multiply both sides by RT to get that variable out of the denominator. What that means is that we are going to cancel out those, and I'm going to get 1 equals 3R over 4. Now I've gone ahead and skipped a step here. Not skipped a step, I've done an extra thing on this step. I don't want 3R over 4. That's not what I'm trying to solve for. I'm trying to solve for R. So I've got to get R out of that fraction. To do so, if I've got 4 in the denominator here, I'll multiply 4 on both sides. Crosses out there, 4 times 1. 4 times 1 is equal to 4, and equals 3R because that canceled out. But again, I don't want 3R, I just want R. So I need to divide by 3, so those will cancel out. And I get 4 over 3. And that's my final answer here. The total resistance is 4 over 3, or 1.3. What you could also notice is that up here, if 1 over RT equals 3 over 4, that's the same thing as RT equals 4 over 3. You can just flip it. It's the inverse. So you can either go through the math, or if you're confident, just flip it. And then we'll be able to check our work at the end and make sure everything made sense. If not, you might have to go back through this business. If you need to, re-watch through there and go carefully through it step by step in order to make sure you can do that part. From here, we need to calculate the current, which is amperage, using Ohm's Law, I equals V over R, at each point. So, in our example, this was a 12-volt power source, maybe a battery or something. And we know the total resistance is 4 over 3 ohms, or 1.33 repeating ohms. So if I've got a 4 ohm resistor there and a 2 ohm resistor there, I don't even need to worry about those because I'm just calculating the total. So the voltage was 12, that's the V. The resistance, 1.3 repeating, there. So 12 divided by 1.3 is 9. This circuit has 9 amps of current running through it. Once I know that, I can do the last 2 steps. Step 3, calculate the current, or amperage, at each resistor. So I know for this whole circuit over here, total voltage, 12. Total resistance, 1.3 repeating ohms. Current, 9 amps. So let's talk about this 4 ohm resistor here. Let's call it resistor 1. Okay, the voltage here is the same. Notice that over here the voltage is the same. This is what's different about parallel circuits, and something you have to memorize is that on the series circuit that we worked with earlier in the week, the amperage is the same at each resistor. On the parallel circuit, like you see here in this configuration, the voltage is the same at each resistor. I'll give you another way to practice this very shortly. So if I equals V over R, I1, the current at resistor 1, is going to equal to 12 volts, because 12 volts everywhere, divided by the 4 ohms of resistance at this spot. We're not worrying about the total resistance, we're looking at this spot. 12 divided by 4 is 3 amps. So the current at resistor 1, 3 amps. 3 amps move through here. Over here for resistor 2, this is a 2 ohm resistor. The voltage is the same as it is everywhere, because that's how parallel circuits work. Ohm's law says current equals voltage divided by resistance. So the current at resistor 2 at this location is going to be the 12 volts, because it's 12 volts everywhere, right? Divided by the 2 ohms, because this is a 2 ohm resistor. 12 divided by 2, 6 amps. Check our work. 3 plus 6 equals 9 amps. That's exactly what we started with. That's what we expect. We've done everything correctly. That's how you do it. Good luck as you try for yourself.